1.3. If you remember, Shabab, the section is about trigonometric substitutions. So we have 3 trigonometric substitutions. And you need to recall how to use them and when to use them. So when we have expression like this, we will use a sine theta. We will put x equals to a sine theta. And if it is the opposite, look, make a connection between this and this. When it is x squared minus a squared, we will use a secant theta. And this is because of the identities. Here, the identity that we will use, it is 1 minus x squared, 1 minus sine squared, which is cosine squared. This will help us to get rid of the radical. And of course, when we have x squared plus a squared or a squared plus x squared, we will use tan, x equals to a tan theta. So look what will happen if you use with this radical. If you use a equals to a sine theta, the radical will be a cosine. Because theta is here, no need for the absolute value. And this will be the reference triangle. It is important to have it if you need to substitute back. With tan, if you use x as tan, you will get the radical as secant. And if you put x equals to secant, you will get the radical as tan. And again, because of this, tan is positive. But we put here just the absolute value to remind you about it, because in some trigonometric definite integrals, you may need to consider the positive and the negative signs of tan or secant or whatever. So it is very important to have the reference triangle if you want to substitute back. If you remember, we have solved this here because we have 4 plus x squared. We will use x equals to 2 tan theta. This is a squared, this is a. And of course, don't forget also to find the x and to find the radical. What is inside the radical here will be the square root of this, which will be secant. Here it is. The absolute value of secant, it is secant. Cancel. Now to substitute back, look, to substitute back, you need to consider the reference triangle. How to do that? From the first substitution that you did. So here it is. This is a tan theta equals to x over a. Let me change the color here or make it a little bit wider. I think let's take this color is okay. Good. Now here you have 9 minus x squared, so use this substitution. X equals 3 sine theta. And don't forget to find the x. The radical will be in terms of cosine because it is positive, and so on. Substitute back. When you have double angle, use the identities. You use the trigonometric identities to help you to go back to the original variable. When the coefficient of x squared is not 1, take it as a common factor, and then use your substitution. Trigonometric substitution. Why I'm thinking about use substitution? Because we will have an example about that. Similarly here, ya shabab, we have 9 minus, we will use x equals sine theta. We did solve these, all of them in the previous class. Just I'm refreshing your memory. So you here to find the area enclosed by an ellipse, you need to solve it for y, then find the area of 1 quadrant, then multiply by 4. Here we use x equals tan theta. And I think the last one, this one. Maybe we stopped at this example. I'm not sure with you where we are, but let's just recall it together. So in this example, which trigonometric substitution we can use? Who can tell me? Let me ask you, shabab, specific students. Muhammad al-Dali, ya Muhammad, Abdurrahman al-Fahid. What do you think, Abdurrahman? Which substitution, if we want to use the trigonometric substitution?
2 tan theta.
2 tan theta, Allah yarda alayk. Do we need here to use the trigonometric substitution, Abdurrahman? Or there is an easier way?
Yeah, أعتقد U Substitution.
Yes, excellent, ya Abdurrahman. Let me ask Nawaf al-Mutlaq. Ya Nawaf, what is the U substitution that we can use here?
Direct substitution. Like x squared plus 4.
What is inside the radical? We will put it as what? We will put it as if you want to use, you can use this substitution also. It is the same. They are equivalent. But in both way, what is the inner function equals to u. Yes, you're right. So this is u, ya shabab, and it will be easier, by the way. Why it is easier? Because what will be du? Du will be 2x dx. So we have x dx. Here it is. So the x dx, now x dx will be just du over 2. So it is easier to use here the direct substitution, the U substitution. But you still have the choice to use the trigonometric. Now, ya shabab, if it was 1 here, if it is 1 here, for example, no x, in this case, you have to use this trigonometric substitution. If it is x squared, x to the power 3, x to the power 4, you have to use the trigonometric substitution. It is only in this case you can use the direct substitution. I mentioned this here, so it would be possible to use the trigonometric substitution, but it is easier to use the U substitution. By direct, they mean the direct substitution, they mean U substitution. And of course, you know, Shabab, if you use it, this is what you are going to have, and you know how to integrate this. This is not our subject today. Now, again here, if we have x here, it is good to use the direct substitution. But without x here, when it is like this, indeed, in this case, we need to use the trigonometric substitution. Abdulaziz Al-Wahabi, what is the substitution that we can use here, Abdulaziz? What is the trigonometric substitution we can use, Abdulaziz?
I think a secant theta.
You are right. You are right. What you are thinking about is right. Hassan Abdulaziz. So here we will put x equals to a secant theta. And of course, we will assume to have the inverse. We will assume that theta is in this interval, just to have the inverse of the function. Now, accordingly, what we will have, you need to find the x. What is the x? This is the x. If this is x, this is the x. And the radical of for sure, the radical will be a tan theta at the end. Because in the first quadrant, this is the first quadrant. This is the third quadrant. In both of them, tan is positive. So no need for the absolute value. Now you will go to your integral. This is the integral now, ya shabab. This is the integral. What we will do, we will consider this as what? As a tan theta. And the dx, it is a secant theta, tan theta d theta. We will cancel, and look what we will have. After the cancellation, we will have the integral of secant theta. And this is not a new integral. We evaluated this integral several times. It is ln secant theta plus tan theta plus c. Now it is about how to substitute back. For this part, it is easy from here. Secant theta is what? Secant theta, it is x over a. So this one, it will be x over a. Okay. The question is, what is tan theta? Tan theta, you can find it from the integral. Since secant theta, it is x over a, so it is the hypotenuse over the adjacent. By Pythagorean theorem, this will be the square root of x squared minus a squared. Tangent theta will be the opposite over the adjacent. So it will be the radical over a. You can simplify this, ya shabab, because you can write this as what? You can write this as ln the absolute value of x plus the square root of x squared minus a squared all over a. And by the properties of the logarithms, you can write this as ln the numerator minus ln the denominator. A is positive. So because of that, we have ln the absolute value of a, it is a. Also, by the way, it is good to mention that, but next, no problem. So now this one, you can write it as a new constant. Let's call it C1, for example. Here it is. This is C1. Or you can just call it C, no problem, because we said that it is, ya shabab, it is just a matter of a constant. Now you can update your table of integrals and add this integral to it. This formula number 1, it tells you that if you have the integral of dx over square root of x squared minus a squared, it is just ln the absolute value of x plus this. Okay. By the way, we have the same formula if this is a plus. If this is a plus, we will use tan. We will not use this substitution. We will use a tangent theta. And it will be the same, just this will be plus. Instead of minus, this will be plus. As you will see in the next exercise. Now, as you can see here, Shabab, this is solution number 1. So it means that there is another way or another solution. The another solution is what? Is by using the hyperbolic substitutions. I will mention it just for you to let you have an idea about it. but I have noticed that they don't use it. They don't. I think I didn't find any old exam question. I'm not sure about that, but I didn't find old exam questions about hyperbolic substitution. We don't focus on that, but it is good to have an idea about it. So for the same integral here, let me repeat. We can use a secant theta, but also we can put x equals to a cosine hyperbolic theta. This is another substitution. So when you can use secant, you can use cosine theta or cosine hyperbolic theta. But usually we prefer above the trigonometric substitutions. We will see why. Now, why cosine? Why not sine t? Why not sine hyperbolic? The reason indeed, the reason is this identity. We use this identity. Okay? Now, just to recall, Shabab, if you have now, we have x squared minus 1. So it will be x squared minus 1. What is x here? What is x that cancel the radical? So if we cancel this, the radical. From this identity, you know, ya Shabab, it is a plus in the case of cosine and cosine. In the case of trigonometric, here it is minus. So here, if you look at it, cosine y squared equals to what? Sine hyperbolic squared y plus 1. It is 1 plus. So here we don't have a plus. So it is not good to put x equals to cosine, to sine. So if we put x equals to cosine t, we will have x squared plus 1, and we don't have x squared plus 1. We need x squared minus 1. So we will use the another identity. What is the another identity? It is this. Solve it for sine. What will be? Cosine hyperbolic squared t minus 1 equals to sine squared, sine hyperbolic squared. So this is x squared minus 1, if we want. So here, if we put this equals to cosine squared t, this will be sine hyperbolic t, and this will be at the end sine hyperbolic t. Here it is, x squared minus a squared. Take it, let x equals to a cosine, so it will be a squared cosine. Take a squared as common factor. This is sine hyperbolic, it is a. A is positive, and also this is true for positive x. So we have sign here positive because of that. So now the radical, this radical will be a sine t. So you need to find dx, by the way. What is good about hyperbolic substitutions, that if x is cosine or sine, of course, that the x will be the same but with negative, sine or cosine but positive, no negative derivatives there. So this is the x, ya shabab. This is the radical. Cancel now. A with a, look, we have the integral of dt, which is t. And it is easier. Look, the result, I believe that it is the same. And it is easier. Now t, what is t? To find t, recall that x equals to a cosine t. Here it is. Divide by a cosine t. Now cosine hyperbolic t equals to x over a. T will be the cosine inverse. And this is why, ya shabab, we don't focus on this type of integrals or the hyperbolic substitutions, because they are about the inverse of the hyperbolic inverse functions. And if you recall in section 3.11 in Math 101, they skipped this part of the inverse. We didn't focus on them too much. So look at this integral, the same integral that we had before, but it looks like it is different. Formula number 2, it is different from formula number 1. You recall the formula number 1, it was like this: ln x plus the square root of x squared minus a squared plus c. Indeed, they look different, but in fact they are equivalent. Just you need to recall the formula in 3.11. You know, ya shabab, that we can write the inverse hyperbolic functions in terms of ln, because the cosine and the cosine hyperbolic and the sine hyperbolic originally are written as exponential functions, the sum and the difference of exponential functions. So this is why their inverse also is in terms of logarithmic functions. So mainly يا شباب we will focus on this one. This is what we are going to focus on. We will not, rarely you can find this in the integrals table. You can do the same يا شباب when you have plus. This is when we have x squared minus a squared. You can do the same when you have a plus. You can use here you can use the trigonometric substitutions a tan theta, or you can use x equals to a sine t. Here it is, or sine theta, whatever. It is just a matter of notation. And these integrals, both of them are equivalent to each other by the formula 311.3. Again, as I said, Shabab, the hyperbolic substitution can be used in the place of trigonometric substitutions. We have two hyperbolic substitutions. And sometimes they lead to simpler answers, sometimes not. But we usually use trigonometric substitution. Why? Because trigonometric identities are more familiar than the hyperbolic. We use almost every day trigonometric identities. So we are aware about them more than the hyperbolic identities. So what are the hyperbolic substitutions that we can use? If you have integral x squared minus a squared, you can use cosine. And this is the same place that you can use secant instead. Okay. The another one, if you put this substitution, you will get this at the end. The another one, when you have a plus, and this is the same place that we can use tan theta, in which we can use tan. So you can use sine hyperbolic t. And again, in the same way, by the same way, your integral, your radical will be like this. The only case that we are not going to use the hyperbolic substitution in is when we have a squared minus x squared. No identity will help you with that from the hyperbolic substitutions. So my advice is, don't use them unless it is stated for you to use them. Use the trigonometric substitutions. And I'd like to summarize what we did before by introducing this table of integrals, that you can update now your table of integrals and add these integrals. But again, I don't advise you to memorize them if you can prove them, unless you practice and solve and you memorize them by default. Let me help you how to recall this, or how to connect these integrals with the previous ones that you know. Let me ask ya Shabab now, Muhammad al-Nasir, what is the integral of this? What is this, Muhammad al-Nasir? What is the integral of 1 over x squared plus 1?
Wait.
What is it, Muhammad?
Ln x power.
No, Muhammad, be careful. It is direct one. انت سويت table. Do you have a table of integrals?
Yeah.
So what is it? إذا عندك table المفروض يكون قدام عينك الحين، قدام راسك. أنا قلت لكم يا شباب write down your own table and put it in front of you, next to your office, next to your bed. What is this? Let me ask another student يا محمد. للأسف please يا محمد. أسامة واكد. Usama, what is this integral? Usama is absent. Is not responding. Good. Yasir al-Qahtani. Yasir al-Qahtani is absent also. Ali al-Qahtani. Yeah, Ali.
Yes, mister.
What is this integral equals to?
The second one.
This one. I'm asking about this, Ali.
This one will be arctan.
Tan inverse. You are right. Yes.
Yes.
This is tan inverse x plus c. Thank you, Ali. Yeah, Shabab, this is direct because the derivative of tan inverse is this. So it is of antiderivative. Please, Allah يرضى عليكم. احنا ما ينفع نتبع خطوة وانتم ما بتتابعوا. So now this is equals to tan inverse. لاحظوا يا شباب في شبه ما بين هذا وهذا. You can connect them, okay? So only here what is different here, that here we have, instead of 1, we have a squared instead of this one, and it is the same. So if you have here, instead of 1, a squared, you will have here just a, and here you will have 1 over a, just like that. Okay, now let me ask now another question. I will ask this time, I will ask Walid Ba'agil. Yeah, Walid, what is the integral of 1 over square root of 1 minus x squared dx? What is this equals to?
Sine inverse.
This is sine inverse what?
Sine inverse x.
Sine inverse x, ya Walid. Ahsan, thank you. So now, ya Shabab, when you have here a, instead of 1, you have a squared. Here you will have also x over a. Here you don't have 1 over a. It will be cancelled, look, by the substitution. Here, by the way, if you want to solve it, use a equals to tan theta. If you want to use the trigonometric substitutions, use x equals to tan theta. Here, use x equals to a sine theta. And you will get the same answer by the same way. In this integral, we did solve this, ya Shabab, in the previous examples. Look here, when it is a plus, it is a plus, and when it is minus, it is minus. Just use here, if it is a plus, for the plus, use x equals to a tan theta, tangent theta. For the negative case, use x equals to what? A secant theta. In both cases, you have the integral in limit. Also here, you can use the hyperbolic substitution, but I don't advise you to do that. You can do it also. But you will get the results in terms of cosine hyperbolic inverse and sine hyperbolic inverse. The one that we didn't mention today, but I will ask you, Shabab, to solve it. Please try to solve this by yourself. What is the substitution that you need to use here? Just here, you need to put x equals what? A secant theta. Look here, we don't have radical, but you can solve it with this substitution. Again, if you can recall this, it is not bad, but I don't believe that it is good to have so many formulas to recall. Let's go to the next example. We have here an interesting example about a situation that we have rational powers, not radicals directly. And some of you, they may look at this one and say, oh, this is not good because I don't have here a radical, so I cannot use the trigonometric substitution. Indeed, you can. So what is the substitution that can work here very well? First of all, to make it more clear for yourself, you know that the power 3 over 2, it is just the radical to the power 3, or to the power 3, or to the power half. It is up to you. So write it as a radical to the power 3. Now in this radical, so this integral will becomes like this. Integral of from 0 to 3 square root of 3 over 2, x cubed over square root of 4x squared plus 9 all to the power 3 dx. Now you need to think about the good substitution or the appropriate substitution for this integral. Again, the coefficient of x squared here, the coefficient of x squared is not 1. So you have two methods. One way is to write it as 2x squared, I'm talking about the radical, plus 3 squared. And what we will put here, we will put 2x equals to tan theta, or 3 tan theta. Am I right?
Yes.
3 tan theta. But I think you will not think about this one. You may think about this one. You will take 4 as a common factor, and it will be x squared over 9 over 4. Then you will take 4 out, it will be 2 x squared plus 9 over 4. Again, this is 3 over 2 all squared. 3 over 2 all squared. So now you will think about putting what? You will put now here, the substitution, you will put x equals to what?
3 over 2
tan theta. And I think they are equivalent, clearly. But I think this is easier from the beginning. Okay, but you may forget something if you didn't do that. Good. Khalas, if you realize that, you will use this substitution. And this will be dx. And don't forget to change here the limits, because here you have definite integral. And when you have definite integrals, it will be easy. You don't need the reference triangle. You don't need to substitute back. As you change the limits of the integral, you can evaluate it as an indefinite integral and substitute at the end. It is up to you. Now, so how to substitute يا شباب here? From this formula. We have x equals to 3 over 2 tan theta. So this means that what? If x is 0, what we will have? If x is 0, we will have 0 equals to 3 over 2 tan theta. Which means that tan theta is 0. Which means that theta is 0. Now, if x is pi over 3, no, if x is 3, if it is 3 square root of 3 over 2, we will have what? 3 square root of 3 over 2 equals to 3 over 2 tan theta. And of course, multiply both sides by 2, divide both sides by 3, you will have square root of 3 equals to tan theta. Now, what is the angle that it's tan is square root of 3? And it is between negative pi over 2 and pi over 2, of course. It is pi over 3.
Pi over 3, yes.
Here we are. So now the integral, and what will be the radical, by the way? The radical will be 3. We bought here, if you substitute by x, both x equals this, and you'll have 3 secant theta. This is important because some of you, they forget to evaluate it this way. So our integral will be, this is x to the power 3. This is x to the power 3. This is the radical. Don't forget here now to raise it to the power 3. This one is to the power 3 in the denominator. So this is to the power 3. So this one, it will be 3 secant theta to the power 3. So here it is. And this is the x. I'm afraid that most of you, they forget the x. So don't forget the x. Here, this is the x. Now let's simplify. If you simplify it, your expression, you will have an integral like this. Now, ya shabab, how to solve this integral? This is also not a clear or direct integral. Any suggestion what we can do? Let me ask Abdulaziz al-Milham. Are you here, Abdulaziz?
Yes, Victor.
وصلت أخيرا Abdulaziz?
I'm here.
Abdulaziz al-Milham. This is Khalid al-Milham.
Abdulaziz or Khalid?
I said Abdulaziz.
Yes, Abdulaziz.
Why your name is Khalid, Abdulaziz?
What? Are you sure?
Yes. You are Khalid al-Milham. Who is speaking right now is Khalid al-Milham.
I don't.
Yes,
I don't know how.
Khalid's here. I have Khalid al-Milham and Khalid al-Milham. What is wrong? Abdulaziz, I mentioned that you are absent in the last 4 classes.
No, I'm here.
No, your name has been changed. You may change your name. This is not the time to discuss that. The last 4 classes you were absent in my attendance because you changed.
Can we talk about that in the office hour?
Yes. Yes, please. So now I'm asking Abdulaziz al-Milham.
Okay, well.
Yalla Abdulaziz, what you can do about this integral?
U substitution.
What is the U substitution here? If you put U equals to what? What will be the U? Do you have U and the U inside this integral? No. Give me any U, you will think about it. If you put U equals to tan, du, it is secant square theta. There is no secant square theta. If you put U equals to secant theta, du will be secant theta tan theta, and you don't have this expression. What you should do here, ya shabab, let me ask Abdullah Sayer. Abdullah.
Hello, doctor.
Yalla, Abdullah, what do you think? What we can do here?
We take sec as a U.
No, تونا مخلصين الكلام هذا يا عبد الله. انت ما كنت معانا. عموما يا شباب, let me give you this step. We don't have much time. So what is good here, ya shabab, what you should do, you should write it in terms of sine and cosine. So it will be sine cubed over cosine cubed multiplied by 1 over cosecant. You know, it is the reciprocal of cosine, so it will be cosine theta, d theta. And this is the integral. Now you will cancel this with the squared and you'll have squared here. So it will be the integral, your integral will be sine to the power 3 over cosine squared. So write it in terms of sine and cosine. This is the first step. Again, let me repeat this question. Abdulaziz al-Khatib, Abdulaziz, how to find now this integral? Yeah, Abdul Aziz.
We use trigonometric
What? Trigonometric what?
rules.
So tell me what to do.
Tan cubed equals sin.
احنا خلصنا هنا. احنا I'm asking about this يا عبد العزيز. صح لو سمحت. We are here now. Sine to the power 3 over cosine squared.
Equals 1 minus cosine squared theta.
There is something that you have to do before يا عبد العزيز. في شغلة المفروض نسويها قبل. Look what we have here. Look here يا شباب. So what we should do?
Can I ask?
We should write it like this. This is the first step that you need to do. This is ya shabab 7.2, the section that we just have finished last week. So now what you need to do, now you can use Abdul Aziz what you said. Abdul Aziz said we can use the trigonometric identities. Now what is the next step? What we need to do next? Ya Mshari Hamad. What we will do next يا مشاري?
نستخدم أحد نفس trigonometric function.
Tell me what to do. This will tell you يا مشاري to what to do. What is this? This will be U.
Yeah.
So what is U? Cosine theta. If this is the U, this is U. So it means that we need to write this. We need to write this in terms of what? In terms of cosine. So this will be the integral of what? Sine squared. It is 1 minus cosine squared theta over cosine squared theta d cosine theta. This is the derivative of cosine theta. So this is the integral that we will do. We will just write it this way. Sine cubed. We will write it as sine squared, and this is sine squared. Now this is du. This will be u. By using u equals to this will be the integral. And you need also to change, of course, don't forget to change the, when theta is 0, cosine theta is 1. When theta is pi over 3, cosine pi over 3 is a half. So now your new integral will be like this, 1 minus u squared over u squared du. Okay?
Okay.
Sorry. Be careful.
Okay.
Yes, your grades in the quizzes, you need to defend them. So you will have, I will hold your grades in the quizzes, and you need to defend your grades. You need to prove to me that you deserve the grades that you have in the quizzes, okay? Good. Let me now, Shabab, continue how to evaluate this integral. It is so easy, just expand. So if you expand, this negative will be cancelled with this negative. So you will reorder this. U squared over u squared is 1. This is 1 over u squared. It will be u to the power negative 1. The half, the negative, cancelled with that negative. Integrate, evaluate from the upper to minus the lower. Look here, we don't need the reference triangle. We don't need to substitute back. This is in the case of the definite integral. The last example, Shabab, is about when you have integrals like this. Now, if you have integral like this, you need to complete the square before using the trigonometric substitutions, because usually when we have u squared minus a squared, or square root of a squared minus u squared, or something like this. But of course, when we have something like this, we need to complete the square first. Okay? So here, to complete the square, you know what to do, ya shabab. You will take a negative here as a common factor. The coefficient of x squared must be positive. So we will take this negative as a common factor. So we will have it now like here. We can complete the square now inside. So it will be x squared plus 2x plus 1. We add 1 and subtract 1. This is the one that we subtract. It will be negative minus negative. And we have this. Now, this integral will be equals to what? The integral of x over square root of 4 minus x plus 1 all squared dx. Now, what is the right substitution here to use? We can use directly, we can put x plus 1 equals to 2 sine theta, or you can use the U substitution as he did here. What he did, he put u equals to x plus 1. Accordingly, x will be u minus 1, and the x will be the same as du. So this, your integral will be like this. 4 minus u squared, and this x will be u minus 1, and dx is the same as du. But I believe that you can do that without, you don't need this substitution. Anyway, what you will do here now, Shabab, to continue, you need to put u equals to what? 2 sine theta. Du will be 2 cosine theta, and it is the same here. Dx will be 2 cosine theta d theta. Now, by using the trigonometric substitutions, you have this integral, and you know how to find this, and you will cancel, and you will be able to evaluate this integral. Again, Shabab, you can also, this one, you can separate it into two integrals and solve it, but this one is good. It is quite similar to what we have. Don't forget that you need to substitute back. Here you have sine inverse u over 2. U is, of course, x plus 1 over 2. And you need, in this case, how to find cosine theta. Cosine theta will be just, what is sine theta? Sine theta, it is u over 2, and you need to substitute back and use the triangle, the reference triangle. These are some exercises for you with the final answer to practice and check. And I think we, in 10 minutes or 12 minutes, we need to solve the recitation exercises quickly, just to go over the main ideas. Who can tell me what to do with this one? How to integrate or evaluate this integral? Yes, Shabab. Anyone? Abdulaziz Al-Jaad, Abdulaziz. Abdulaziz, what do you think, Shabab? Can we use here the trigonometric substitutions?
Can use
Or it
substitution.
is better to use the U substitution?
U substitution.
Direct would be easier.
U substitution.
Direct.
The direct substitution is easier. So look here, ya Shabab, what we have. We have 1 minus 4x squared all to the power half multiplied by x dx. So what I did, I just write x here. Reorder your terms. Now this will tells you to put u. This is du. It tells you to take du to be what? So now bot u equals 2. What is inside the radical, Shabab? All of this.
1 minus
I
4x.
don't know why some of you they think about putting u equal x squared only. No need. But all what is inside the radical, but it equals to u. So in this case, du will be 2x dx. You have x dx. In this case, if you did that, but here it is better to put u equals to 1 minus 4x squared. Du will be what? Negative. Don't forget the negative. Negative 8x dx. You have x dx, so x dx will be just du over negative 8. So this integral will be u to the power half. This x dx, it is just du over negative 8. You need, ya Shabab, now to find the limits. When x is 0, when x is half, what will happen? If x is 0, this will be 1. U will be 1. When x is half, this will be a half squared fourth 1 minus 1 0. So it will be from 1 to 0. And you can write this as negative 1 over 8. And by the way, you can change this negative. It's okay. And you know how to integrate u to the power half. It is u to the power 3 over 2 multiplied by 2 over 3. From where to where? From 1 to 0, which will be, of course, 1 over 12 as shown in the final answer there. But again, you can use also trigonometric substitution, Shabab, as well, but it will not be simpler. Try that, please. What is the substitution that you can use here, Shabab? You can take 4 as a common factor, or you just put 2x equals to 1 what? Sine or cosine or what, Shabab? Or tan or secant? Sine. You will put this as sine theta, which is similar to putting x equals to a half of sine theta. You can use this substitution, Shabab, and it works also, but it is not easier than the direct substitution. Again, this is what we should do here, Shabab. We need to complete
The square.
So this will be the integral of, let me help you how to complete the square. This is 5. Here I need the coefficient of x squared to be positive 1. It is negative 1. So I will take negative as a common factor between these two terms. So it will be negative x squared minus 4x. I reorder the terms, the positive at the beginning, dx. This is equals to the square root of what? 5 minus, I will add what يا شباب? I will add 4 and subtract 4 at the same time. So this will be the integral of what?
9 minus
5 minus, here x minus 2 all squared. This negative multiplied by this negative, it will be positive. Positive 4 plus 5, it will be 9. So this is 9 dx. Now what we will do, we will, to solve this integral, we will use trigonometric substitutions. You can use U substitution at the beginning. You can put U equals to x minus 2. du will be dx, and it is not a big deal طبعا. For me, I can do it like this يا شباب. It will be, I will put this x minus 2 equals to, if I have it like this, 9 minus u squared, I will put u equals to what? 3 sine theta. So I will do the same here. Okay, now according to that, dx will be what? 3 cosine theta d theta. Now I will go back to my integral. This and again, what will be my integral? The radical will be what? It will be 3 cosine theta, because this will be 9 minus 9 sine squared. 9 will go out as a 3. 1 minus sine squared is cosine squared. Under the radical, it will be cosine theta. So here we will have what? 3 cosine theta, and this is in place of the radical, and dx is 3 cosine theta d theta. This integral will be 9. The integral of cosine square theta d theta equals to 9 multiplied by what? The integral of 1 plus cosine 2 theta. You know how to evaluate cosine square theta. You can find this integral, shabab. It is has been done several times before. And this is the final answer. You need to substitute back. You need to draw your triangle. Just let me show you, طبعا, if you want to draw your triangle, how it looks like. According to this, what will be the triangle in this case? This is theta. So sine theta will be x minus 2 over 3. X minus 2 over 3. The opposite over the hypotenuse. And this one here, it will be what? It will be 9. This one squared minus this one squared, which is the same as the first radical that we have. And this is the final answer, Shabab. This is a nice integral also. What do you think? How to find this integral? Any idea? Abdulaziz Al-Jaid. If you have this integral, what is the first thing that comes to your mind?
1 plus u equals to 1 plus sine square.
So you will put u equals to 1 plus sine squared t. What will be du, Abdulaziz?
Du will equals to, I guess, just give me a minute.
It will be 2 sine t cosine t dt. Do you have this inside the integral? Do you have du there in the integral?
No.
It is very bad idea.
Yeah.
You need to think about something else, Abdulaziz. It's okay. You have to think about something. You need to think, I should do something. So let me ask Ali Nimr. Ya Ali. Ali, what do you think? This substitution doesn't work. What do you think, Ya Ali? What is the substitution that we may use here?
Can't use to sine cosine. Oh, Allah, I don't know, but
no problem, Ya Ali. You are here to know. You are here to know. You are here to learn. Don't worry about that. Abdullah Shimri. Abdullah Shimri. Abdullah Shimri. Can you hear me, Abdullah? Abdullah Shimri. Abdullah Shimri, you are absent. Abdullah Shimri, if you are hearing me, because I know that you are there, your grades are hold. All your grades in the quizzes are hold until you prove you deserve them. So your grades in all of previous quizzes will be 0 unless you prove to me that you deserve them. When I call you, always you didn't respond. So I need to see you during the office hours, and you need to have oral exam to prove that you deserve the grades that you solve and the grades that you obtained, and you solve the quizzes by yourself, not without any help. Okay, so let me ask Turkey Al-Jaid. Yeah, Turkey.
Yes, doctor.
What is the substitution that we can use here?
1 plus sine square t.
وينك احنا قلنا قبل هذا قالها عبد العزيز وما زبطت. لا تنام صحصحوا معانا الله يرضى عليكم. So it doesn't work. The substitution that we need to work here يا شباب, this is the final answer. I want you to solve and check the final answer. The substitution that you can use here يا شباب, it will tells you, this will tells you what to do. This will be du. So if du is cosine t dt, what will be u? It will be sine t. So both sine t, the sine here inside, both it equals to u. This is the substitution that we can use. Now here you can do it directly. This will be equals to ln u plus the square root of 1 plus u squared, if you remember. This is the one that I gave you as a formula. Or you can use trigonometric substitution. So if you want to use the trigonometric substitution here, because we have 1 plus, we will put u equals to tangent theta. Du will be secant theta, and you have this. You need to change the limits every time here. Look what they were, and here what they are, and finally what they are. So don't forget to change the limits of the integral. Now, when you have this integral, it will be so easy now. It will be the integral of secant theta, and you know what is the integral of secant theta. It is ln the absolute value of secant theta plus tan theta plus, of course, from 0 to pi over 4. Evaluate, you will have this integral. Unfortunately, Shabab, I don't know what is wrong with you. You didn't revise day by day, week by week. This is not good at all. Our next exercise is about how to find the area of the region bounded by this hyperbola. By the way, this is a hyperbola that you can write like this in the standard form. And this will tell you that it is, of course, this is a squared b squared. It will be, of course, a horizontal a triangle that's centered at the origin, and the vertex here, it is 2 and -2, the two vertices. And what we want here to find the area enclosed by this hyperbola and this line, x equals 3. This is x equals 3. So this is the region that here, this region is the region that you want to find the area of. So you can do it by 2 methods. Method number 1 is to draw your typical rectangle to be a vertical one. And this means that you will integrate with respect to x. The area will be in terms of x if you did that. Now you need to find the upper curve, y top, and the lower curve, y bottom. What is y here? What is y here? So you need to solve this equation for y. Here we are. We solve it for y. So this is y. If it is above the x-axis, it will be the positive part. If it is below the x-axis, it will be the negative part. And according to that, your integral will be the upper curve. This is y upper minus y lower. Okay. Now, from where to integrate? You will integrate with respect to x. X is from where to where? From 2 to 3. How to know, ya shabab, it is 2? Just when x is what? This y will be 0. Y will be 0 if what? Because this is the x-axis. Y will be 0 if x is 2 or -2. But this is not in our region, so we will put x equals to 2. Just in a minute, ya shabab. So now you will evaluate this integral from 2 to 3. You know how to do that by what? By trigonometric substitution. You will put x equals to secant theta. And then you will simplify. The problem here that the integral that you will have, it is more complicated. Look what we have. We have an integral that we need to recall. This is, of course, you need here to go to 7.2. If you remember 7.2, example number 8.
Integration by parts.
We did this, of course, there. And of course, you need to use integration by parts to solve such integral. And this is what you have after that. You will simplify, and this is the final answer. Unfortunately, the time didn't allow us to solve the last one, and it is easier, interesting problem. And also, I have put here the solution for you. You can go over it in details. And if you have something that is not clear for you, you can ask me about it during the office hours. This is all what we have for today.